Okay, we have here an interesting integral today from the UNSW Integration Bee 2024, round 2, problem 8. We have the integral from 1 to infinity, arctan of x over x squared dx. Okay, I think I may have done this problem before, but I'm not really sure. But to get started with this, what I was thinking we could do is, just because we have an x squared in the denominator, I was thinking what I could try as a u substitution. What I want to do is u equal to 1 over x. Then we can just solve for x and we get x equals 1 over u. And then when we take a derivative, this becomes minus 1 over u squared du. And that's exactly what I wanted, because I'm thinking that u squared right there is going to give me some cancellation later on here. So let's just go ahead with this, making this substitution. So looking at infinity, and we plug infinity in here. When we plug infinity in here for x, this is going to be going to 0 for our u value. Then here, plugging in 1, we're going to have our u value at 1. Then arctan is just going to become arctan of 1 over u here. X squared is going to become 1 over u squared. And our dx is going to be this minus 1 over u squared du. I could take the minus sign right here and we'll just use it to swap the bounds. So now this is going to be, this will be going from 0 to 1 over here. But then here, this u squared, so this is going to cancel out with this. And now I think this does seem simpler this way. And then here for this, what I want to do is just the normal thing that we do when we have arctan and integrals. We usually want to do integration by parts. I'll just kind of create a 1 in front so that we'll come over here. I'll do the DI method or tabular integration. I'll just differentiate this. So we'll differentiate arctan 1 over u, and then we'll integrate this 1. Going ahead and differentiating, this is going to become 1 over this 1 over u squared plus 1. But then we need the chain rule on this derivative of this we found before. It's just going to be minus 1 over u squared. And then over here, integrating 1, this is just going to be u. So putting it together, we're going to have part of the solution right there on the diagonal. This is going to be u arctan 1 over u. And this is going to be evaluated from 0 to 1. And then here, minus times minus is going to be plus. This is going to be, and this row is going to be an integral. So when we do this, what's going to happen is we're going to have this u in the numerator. But then when we multiply on the u squared here, it's going to cancel with this term here. And so this first term is just going to be a 1. And then u squared times 1 is just going to give me u squared. Now from here, we can do another substitution on this thing right here. We'll do a t substitution. So I'll set t equal to 1 plus u squared. Then we take a derivative. Then our dt value is just going to be 2u du. But I can create this 2 right here in order that my numerator is going to be exactly the dt value multiplied by 1/2 out front so that we're not changing it. So then we'll go ahead with this substitution now. So this is going to be 1/2. Evaluating first at 1. So we plug 1 in there for u. 1 plus 1, we're going to have 2 for our upper bound. And then we plug 0 in here. The lower bound is just going to be 1. And then again, this is all of our dt right here. So this is going to transform into just dt over t. Sorry, this over here is actually a 1 over u before we evaluate this. So we need to put a 1 over u in here. But now let's just go ahead and evaluate this over here. So first evaluating at 1, we're going to have 1 times arctan of 1. That's just going to be pi over 4 here. Then minus, evaluating at 0, we're going to have 0. And then here we're going to have arctan of 1 over 0. This is going to be like arctan when it's going to infinity. That's going to be pi over 2. But it's not going to matter because we're multiplying at 0 times pi over 2. So that part goes away. So this whole thing over here is just going to be pi over 4. Then we're going to have this piece. This is going to be 1/2. Integral here, this is just going to be natural log absolute value of t, and we just need to evaluate from 1 to 2. So going ahead with this, we're going to have our pi over 4 plus 1/2 in front. Then evaluating at 2, this is just going to become natural log of 2. We'll just leave that. Then next, minus evaluating at 1, we get natural log of 1, but natural log of 1 is 0, so that goes away. And so for my final solution for this, we just get pi over 4 plus 1/2 natural log of 2. Okay, there you have it. Good one from UNSW 2024. Thanks everyone for watching. Have a good day.